We're going to continue with vectors today, and we're going to be learning how to find the magnitude of vectors. So the magnitude of a vector is given by the length of the line segment representing it. So I briefly mentioned the magnitude before, and the magnitude is the length of a vector. The magnitude isn't determined by the direction of the vector because it's just a length. So for example, suppose we have the vector AB, and remember we can write that as the lowercase letter a, bold if it's been typed, underlined if it's been handwritten. So we've got 4, -2, that's our column vector, and then we've got the directed line segment drawn here. So 4 along and then 2 down to give us AB vector. So the magnitude of this vector is written, so these 2 straight lines, and we can write it as our vector AB with the arrow above it, but you need these 2 straight lines either side, or your lowercase letter with these 2 straight lines. So if you see these 2 straight lines, that represents the magnitude of a vector. So you can calculate this using Pythagoras. So the process to calculate the magnitude of a vector is derived from Pythagoras' theorem. Because we are essentially trying to calculate the length of this line, we can use the fact that, well, we know we could create a right angle triangle and say it's going 2 down and 4 along. So this length is 2, and then the bottom length is 4, and we can just use Pythagoras' theorem to work that out. But for quickness, we have our magnitude AB is the square root of the first component squared, add the second component squared. So the reason we have the square root is because Pythagoras' theorem is c squared equals a squared plus b squared. So c being the vector length that we're trying to calculate, but because it's c squared, we just want c in its own, so we just want the magnitude on its own, hence why we square root the other side. So we're square rooting each of the components squared and added together. And notice that, so this is 4 squared, notice that we've just got 2 squared. It doesn't matter what sign this is, because -2 times -2 is the same as 2 times 2. So you can sort of eliminate the negatives when you're putting it into the magnitude formula that we're using. So the magnitude of AB is equal to the square root of 4 squared add 2 squared, and you can calculate that. So 4 squared add 2 squared, 16 add 4 to give us 20. If you are given this question in a non-calculator paper, then you want to leave your surd in its simplest form. Okay, so simplifying the surds to get 2√5. Or if it's a calculator paper, you can just pop that into your calculator to get a decimal. Okay, so you want to either simplify your surd if it's non-calculator, or whatever the question's asking you to, or leave it as a decimal, and then you would round that to about 2 decimal places. Let's look at a few more examples. Okay, so we have for A, our vector A is component vector, column vector, is 5, 12. So these are 2 components. To find the magnitude, we're going to write A with these 2 straight lines round about it, and it's the square root of each of these components squared and added together. So it's the square root of 5 squared add 12 squared. So get to the square root of 169. So then the magnitude of A is 13. Again, if we've got some negatives, so we've got our vector B, 3, -4. So we're going to square root each of these components squared, so 3 squared, add 4 squared, and we've eliminated that negative sign because it's not necessary. -4 squared is the same as 4 squared. Because we are calculating a length, we need a positive answer. So always look out for that as well. So square root of 25 is equal to 5. So if you do ever get a negative answer, somewhere along the lines, if you get a negative in your underneath your root sign, you've made a wee mistake somewhere. So these should all be positive. And our last one is vector E. Again, we've got our column vector, which is 2, -5. The magnitude written with these 2 straight lines is the square root of 2 squared add 5 squared. Get the square root of 29. We're going to use a calculator to give us a decimal answer, And when you're ever using decimals in your answer, always write down the unrounded answer first and then round it to either 2 decimal places or whatever the question is asking you to. So I've popped square root of 29 into the calculator, I've got 5.382 out, ... and I've rounded it to 2 decimal places. So if you could copy these examples down, or at least 2 out of the 3, and on the next slide, I'm going to get you to try some yourself. Okay, so if you could pause the video here and try these 3 questions. Calculate the magnitude of the vectors below. Okay, so for the first one, vector D, we've got -6, 8, so you should have the square root, so writing out your magnitude, those 2 straight lines, the magnitude of D equals the square root of 6 squared add 8 squared, to get the square root of 100, which is 10, so the magnitude of D equals to 10. The next one, you should have the magnitude of C, written with those 2 straight lines, is 15 squared add 8 squared, square root of 289, and then you should get the magnitude of C is 17. And lastly, for F, we've got 2 negatives here, -4, -6 for a column vector. So square root each of those components and add them together. Sorry, the square root of each of the components squared added together. To get the square root of 52, pop it in your calculator to get a decimal answer and then round it to 2 decimal places. So well done if you got those. Okay, for this next example, we're going to say that given vector A is 3, -4, and vector B is 1, -2, we have to calculate the magnitude of 2A subtract 3B. So this here is what we spoke about last lesson. We were adding and subtracting vectors and also multiplying them. So we've got a resultant vector here that we want to calculate the length of this resultant vector. Okay, in order to do these questions, this part inside 2A subtract 3B, you need to calculate that first before you go ahead and try to calculate the magnitude, which is the length. So first we want to calculate what 2A subtract 3B is. So you can just substitute in your vectors in place of your vectors A and B. So we've got 2 times vector A, subtract 3 times vector B. So then 2 times 3 is 6, 3 times -4 is -8. Subtract 3 times 1 is 3, 3 times -2 is -6. And then we can go ahead and subtract these now. So 6 subtract 3 is 3, then -8 subtract -6 becomes -8 plus 6 to give us -2. So now we have this resultant column vector for our expression here, and now we can find the magnitude of this. So to find the magnitude of 2A subtract 3B, we've calculated 2A subtract 3B, so we need to do the square root of 3 squared add 2 squared, which is the square root of 13, and then pop it in your calculator to get a decimal answer. If you could pause here and copy this example down, noting that if you're ever to calculate the magnitude of a resultant vector where you've added some together or subtracted, you must calculate what's inside that magnitude first. Okay, so using that example, can you give this one a go? So C equals 4, -1, and vector D is 5, -2. Can you calculate the magnitude of 3C add 2D? Notice that this is an addition and not a subtraction like that previous example. So if you pause here. Okay, so when we're doing these questions, you need to calculate 3C add 2D first. So 3C add 2D equals 3 times our vector C, add 2 times vector D. So 3 times 4 is 12, 3 times -1 is -3, 2 times 5 is 10, 2 times -2 is -4, and then we can add them together. So 12 add 10 is 22, negative 4 add negative 3 add negative 4 is negative 7. We can now calculate the magnitude of this using this column vector. So 22, the square root of 22 squared, add 7 squared to give us the square root of 533. Using your calculator, turn that into a decimal with your unrounded answer as well. So really well done if you got that. So our next example is something we have not spoke about yet, but this is 3D vectors, okay? So far we've only looked at 2D vectors where there's just an x and a y component, but now we've got this z component. Okay, so we're just going to speak about the 3D vectors in component form, which is fairly, really similar to working with 2D vectors in component form. We've just got this extra component at the bottom. So our vector A is 2, 1, 3. So we have to calculate the magnitude of this. And we're just going to apply the same steps as we did previously, but we've just got this extra component at the bottom. So to calculate the magnitude of A, we're just going to take each of these components and square them. So 2 squared, add 1 squared, add 3 squared. And then we can figure out what 2 squared, add 1 squared, add 3 squared is, which is 14. And the magnitude of A is the square root of 14. So we can pop that into a calculator and get an answer. So exactly the same steps, we've just got an extra component that we're just adding on as well. So using that example, here's one for you to try, so if you can pause the video here and give this one a go. Okay, so to find the magnitude of x, you're going to take each of those components and square them. So 2 squared, add 5 squared, add 1 squared. To get the square root of 30, pop it in your calculator to get 5.477 ... So your unrounded answer first, and then round it to 2 decimal places to get 5.48. So really well done if you got that. Again, using our 3D vectors, we are going to look at our fourth and final example, and we're going to apply similar steps to our example 2 questions. So given that vector A, we've got a 3D vector here, so 3 components. Vector A is 5, negative 2, 1, and vector B is 3, 3, negative 4. We have to calculate the magnitude of A subtract 2B. So before we can calculate the magnitude of this, we need to figure out what A subtract 2B is first. So A subtract 2B is vector A. We don't need to multiply that by anything because it's just on its own. Subtract 2 times vector B, and this is how we write that out. So our next line, vector A stays the same because we've not multiplied it by anything. 2 times 3 is 6, 6 again, and then 2 times negative 4 is negative 8. And then we can subtract them. So 5 subtract 6 is negative 1, negative 2 subtract 6 is negative 8, and then 1 subtract negative 8 is positive 9. So we've now got this 3D vector, column vector for A subtract 2B. We can now calculate the magnitude of this. So the magnitude is the square root of 1 squared, add 8 squared, add 9 squared. Again, forgetting about these negatives because it doesn't make a difference. So 1 squared, add 8 squared, add 9 squared. And get square root of 145. Then a decimal answer. Again, if you can copy this down. And one for you to try. So vector A is 1, 3, negative 2. Vector B is 2, negative 1, 3. Can you calculate the magnitude of 3A subtract B? So if you pause here and give this a go. Okay, so first thing we need to do is you need to calculate 3A subtract B first. So 3 times vector A subtract vector B. We're not calculating multiplying that by anything. So 3 times 1 is 3, 3 times 3 is 9, 3 times negative 2 is negative 6, subtract vector B, which is not changed. So then 3 subtract 2 is 1, 9 subtract negative 1 is 10, and then negative 6 subtract 3 is negative 9. We've now got this column vector for our 3a subtract b, so we can calculate the magnitude. So we've got the square root of 1 squared, add 10 squared, add 9 squared. To get the square root of 182, pop it in your calculator to get 13.49 rounded to 2 decimal places. So really well done if you got that.